Hello my dear students, this is P. Venkateshwarlu, PGT Physics. In previous video I explained capacitors which are arranged in series. At the end of expression, so we have to get the equation capacitors which are arranged in series capacitor, final expression 1 by C effective or equivalence is equal to 1 by C1 plus 1 by C2 plus 1 by C3. If we have to take number of capacitors, 1 by C equivalence is equal to 1 by C1 plus 1 by C2 plus 1 by C3 and so on plus 1 by Cn. Clear my children? Based on this, so we have to do one problem. 3 capacitors, each of capacitance 9 picofarad, are connected in series. First one, what is the total capacitance of the combination? Second one, what is the potential difference across each capacitors if the combination is connected to a 120 volt supply? Okay, see here, in this problem they given 3 capacitors of equal capacitance, means C1 is equal to C2 is equal to C3 is equal to 9 picofarad and applied potential difference V is equal to 120, which are arranged in series. See here, this is C1, C2, C3, C1, C2, C3. Yes, this is battery. Now V is equal to 120 volts, we know that. Then how we can find the effective capacitance in this circuit? Clear? So this connection we can say series connection. Series connection means end to end connection. First capacitor negative terminal is connected with second capacitor positive terminal. So this type of connection continues one to another, we can say series circuit, series capacitance circuit. Clear? So whenever capacitors are arranged like this, so which formula we have to use? See here, 1 by C is equal to 1 by C1 plus 1 by C2 plus 1 by C3. Clear? Yes. So here they given equivalent capacitor. That's why required formula is 1 by C equivalence is equal to 1 by C1 plus 1 by C2 plus 1 by C3. So we know that 1 by 9 plus 1 by 9 plus 1 by 9. Okay. 1 by 9, 1 by 9, 1 by 9. How much we can get? Yes, 3 by 9. 3 ones, 3 threes. 1 by C equivalence is equal to 1 by 3. Then C is equal to 3. C is equal to 3 picofarad. Pico means 10 power minus 12, my children. Pico means 10 power minus 12. So in this case, we have to get the final expression, that is capacitance, equivalent capacitance C is equal to 3 picofarad. C equivalence is equal to 3 picofarad. Clear? In this case, how we can find the net charge? How we can find the charge? We know that Q is equal to CV. Q is equal to CV. Yes. So here C is equal to 3 picofarad. Then V is equal to 120 volts. Then total charge Q is equal to what, Nana? 3 picofarad into 120 volts. Okay, 360 picocoulomb. 360 picocoulomb. The total amount of charge 360 picocoulomb or 360 into 10 power minus 12 farad. Sorry, 10 power minus 12 coulomb. Yes, coulomb means it is C. Clear, my children? So individually individually at C1, at C2, at C3, how much charge is required. So means here in this series connection, same charge is passing from C1, C2, C3. Clear? But here potential difference is different. Potential difference is in each capacitance, potential difference will changes. Clear? Clear, my children? So the amount of charge which is passing from positive terminal to negative terminal is, we know that 360 picofarad. So then at each capacitor, what is the potential difference we will find. Okay, so we know that expression Q is equal to CV, then V is equal to how much now? V is equal to Q by C. Okay, then V1 is equal to Q by C1, yes. So what is Q? 360 picocoulomb divided by C1 minus 9 farad, 9 picofarad. Okay, pico gets cancelled. So 940s means 40 volts. Then V2 is equal to Q by C2. C2 also same value, 360 picocoulomb by 9 picofarad, 40 volts. Then V3, how we can find V3? Because here we are arranged same capacitor, means we have to get same potential. V3 is equal to Q by C3, then 360 picocoulomb by 9 picofarad, 9 ones, 940s. Yes, V3 also 40 volts. Okay, clear? So in this scenario, we need to know, we need to give conclusion here. In the throughout this circuit, charge is same, and throughout the circuit, at each capacitor, the potential value changes if capacitor value changes. Clear? Coming to my dear children, capacitors which are arranged in parallel. Capacitors parallel combination. Capacitors parallel combination. First, what is parallel combination? Parallel combination is type of combination in which all positive terminals are connected at one end, all negative terminals connected at another end. Clear? So consider three capacitors. One, say it is C1, say here C2, C3. Okay, here three capacitors, positive terminal connected with one end, and three capacitors, negative terminal connected with another end. Okay, clear? We are applying potential. So here V, it is denoted V. So here in this case, in this parallel circuit, potential difference is constant. Here Q can split into three types. Here you can split into three types. Say it is Q1, Q2, Q3. Okay. In any parallel combination, V is constant. Clear? I or Q changes, current or charge changes. Clear? So we know that capacitors having different values in this circuit. So we know that Q is equal to CV. It is common formula, or C is equal to Q by V. C is equal to Q by V. So in this circuit, potential difference is constant. we know that total charge Q is equal to, at the junction, amount of charge can split into Q1, Q2, Q3. Like that, Q is equal to Q1 plus Q2 plus Q3. So we know that Q is equal to CV and Q1 is equal to C1V, V because of V is constant. Q2 is equal to C2V, Q3 is equal to C3V. So we are substituting these values in this case. CV is equal to C1V plus C2V plus C3V. Okay. Then here V is common. We can remove outside. V C1 plus C2 plus C3. V gets cancelled. Then C equivalence is equal to C1 plus C2 plus C3. Clear, my children? So if we have to take n number of capacitors, C equivalence means the effective or equivalent capacitance which are arranged in parallel. Okay, C equivalence C1 plus C2 plus C3 plus and so on plus Cn. This is for number of capacitors which are arranged in parallel. Clear, my children? So I will give one clarity for you, my children. See, by calculating or by doing derivation to get series and parallel, so we know that for series what we have to get 1 by C equivalence is equal to 1 by C1 plus 1 by C2 plus 1 by C3. Here parallel, C equivalence is equal to C1 plus C2 plus C3. Clear, my children? So, and one more thing, I will give comparison. Okay, my children, I will draw one table, serial number 1, 2, serial number 1 and 2, resistors, capacitors, series, parallel, okay, so important thing. My children, coming to resistor series means what? Like this, we are arranged 1 to 1 connection or n to n connection. It is R1, it is R2, it is R3. Okay, so in this case we can get the expression R is equal to R equivalence is equal to R1 plus R2 plus R3. Okay, then resistors parallel, this is my children. Okay, this is R1, R2, R3. Clear? What is the expression? 1 by R equivalence is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Clear? Coming to capacitors. So capacitors which are connected in series, okay, C1, C2, C3. But by doing some derivation due to some basis, we have to get the equation 1 by C effective is equal to 1 by C1 plus 1 by C2 plus 1 by C2. Okay. Then parallel combination. C1, C2, C3. Okay, what is the parallel combination expression, my children? C effective or C equivalence is equal to C1 plus C2 plus C3. Clear, my children? So once you can go through it, so there is some confusion is there. Please avoid that confusion. Resistors, we have to use this formula for series and one more formula for parallel. So for that opposite capacitors are arranged. Okay, be careful. So in series combination, which is constant, we are using junction rule. So V changes, potential difference changes, but current is same. Current or charge is same. In parallel combination, potential difference is constant and IR Q changes. Clear, my children? Very, very important table. In the circuits shown in figure, find the equivalent capacitance and the charge stored in each capacitor. My children, in this case, I explained problem. So without taking mu, micro. So at last you have to add micro coulomb. Clear? Yes. Coming to problem, my children. In this problem, they given one circuit diagram and which are arranged in parallel, C1, C2, C3 parallel, and 1 farad, 2 farad, 3 farads units with values 1, 2, 3 capacitors. But here applied potential is 100 volts. So in this case, first we have to find C equivalence or C effective. By using formula we have to get. Then after that we have to find total charge. Then we need to find charge on each capacitor. Charge on each capacitor. Okay. So now we need to find what might children equivalent capacitor or effective capacitors. So we know that C1 is equal to C2 is equal to C1 is equal to 1, C2 is equal to C3 is equal to 3. So then what is the formula to get the resultant capacitance in the parallel combination? Yes, formula C is equal to C effective or C equivalence is equal to C1 plus C2 plus C3. Simple. Yes. So how much 1 plus 2 plus 3 is equal to how much? 6 farad. 6 farad. Okay. C equivalence is equal to 6 farad. Yes. Okay. Then what is the total charge? What is the total charge? Total charge Q is equal to CV. So what is Q? See, what is C? 6 into what is V? 100. 600 coulombs. How much value? 600 coulombs. It is denoted not Q, it is denoted C. Now we need to find charge on each capacitor. Charge on each capacitor. Yes. At C1, what is the charge? Okay. Then Q1 is equal to C1V. Q1 is equal to C1V. How much? What is the value of C1? C1 1 into what is the value of potential? 100. Okay, 100 coulomb. Then charge at C2, Q2 is equal to C2V. 2 into 100, 200 coulombs. Next, charge at C3, that is equal to Q3, C3 into V, 3 into 100 is equal to 300 coulombs. Clear, my children? So be careful, my children. Here they given parallel combination. First we need to find equivalent capacitance. 1, 2, 3 capacitors which are arranged in parallel means what is the formula? C is equal to C1 plus C2 plus C3. 1 plus 2 plus 3, 6. Then total charge Q is equal to effective capacitance and V. C into V. C 6 into 100, 600 coulombs. Then we need to find each at each capacitor what is the charge? Q1, Q2, Q3. Clear, my children?